All right, so let's talk about functions now. And learn how to implement and call functions, understand what's meant by the term side effect. There's a long list of things we need to learn about. That list is more for me than it is for you. It's just a checklist. I have to make sure I talk about each of these topics. See, we've been using functions from the very beginning. Main here, this is a function. So a function is a block of code. A function is a sequence of statements. And you execute the function as a whole. You say, run that sequence of statements. Now run this other sequence of statements. Now run that sequence of statements. That's 3 function invocations, 3 function calls. And so it's a way to organize logic. So think of a function as simply a block of code, a sequence of statements. It's a sequence of statements. Some of the statements are looping. So, it's not a simple sequence. It's just us, but nevertheless, it's a sequence of statements. When one statement completes, you do the next one. All right. There is branching and redirection and all that, so that's something else to keep in mind. So main is the required function. You have to have a main, because that's where the execution starts in your program. The compiler looks for this function and makes this what's called the entry point to your code. And let's do let's do this. Let's suppose we read in a value n from the user. And then if n mod 2 is 0, then we're going to print even number. Else, we'll print odd number. So that's a pretty simple program. So 6, that's an even number. Well, let's fix that. Let's print an end line. Six, even number. 7, odd number. So we have a program running there. But let's suppose this, you have to do this with is prime. This is a little easier. So your problem is to have, you've already written a program that decides whether n is prime or not, prints prime or not. And in your lab, you have to move that code into a function. So I'm going to show you how to do it with evenness. So here's code that determines whether the number n is even, which is a lot simpler than code that determines whether n is prime. And so what we want to do is, rather than have the details of that code here, we're going to call a function. I'll call it is even. We pass in n. So this is the function. We call is even. This function will evaluate to true or false. So it returns a Boolean value. It evaluates to a Boolean value. So that one line that we have that decides whether n is even or not, we're going to move that into another part of the program. it's just a matter of organization. And we're going to invoke that code by using the name of the function where we put it, is even. Let's see if it looks like this. So bool is even, integer n. And then we return n mod 2 equals 0. That's how that looks. Let's just see if it runs first, then I'll explain more carefully. 6, even number. 7, odd number. So I just put that little bit of code right here, and I turned it into a function. I mean, normally it's actually typical that some functions are one line. That's a valid function, and you see that a lot. But in our little example here, it doesn't make much sense. But nevertheless, we're using this to illustrate how functions work. So we have one line of code to execute. But the function can have lots of lines. It doesn't have to have one. And what you see here is you've got the group of statements that are substatements of the function. And we only have one statement, which is right there. Of course, the statement, it does a lot, right? We could do something, we could do this. We could say bool, result equals, and then return the result. So this expression here, n mod 2 equals 0, this expression evaluates to true or false because it's a comparison. See, the double equal sign is comparison. So this expression evaluates to true or false. And we store the result in result, and then we return the result. We didn't have to do all that. I'm just showing you. Maybe that helps you understand it. This is the compact way to do it. We're going to evaluate this expression, which is true or false, and then return that. Now the return type is given here. So the function, when the function gets evaluated, it evaluates to an instance of this data type. It evaluates to an instance of this return type. We call it a return type. This function returns values of type bool. This expression evaluates to true or false. We can't do this. Look. Well, we could actually. I don't think the compiler's not going to complain, but it should because the language isn't going to work. And it's not good. But if we did something like this, this will complain. There we go. Another language that would have failed. Not in C++, unfortunately. I would say that's a weakness of the language. But here, this will complain. We're returning a string. I made this expression into a string. And but we're declaring the function as returning a bool. Now the compiler will not generate code to convert this string into a bool or to have the string be considered as a bool. At least I hope not. I can't believe it works. It's ridiculous. Oh, well, it's broken, isn't it? Look how bad this language is. We have a logic error. 7 is even. You see that? I'm going to rag on the language a little bit here. It is an ancient language. Starting a new project, you're not going to want to do it in C++, but there's a huge amount of code out there that uses C++, but there are reasons to use it. But this is an example. It's very hard to get the language to work, to make it easy to catch these kind of bugs. See, I'm returning the wrong data type here, but my compiler doesn't say anything about this. If you're working in Java or C#, then you'll get a complaint here. If you're working in JavaScript or a scripting language, this will be okay because it does lots of automatic conversions. All right. So maybe I'm kind of getting into lots of different topics here. Let's get back to functions. A function has a name. Is-even is the name of the function. It has a return type. A return type, that's the type, that's what the function evaluates to. See, I've highlighted there. There's where we invoke the function. After the function is invoked, it's replaced by data of this return type, bool in this case. Okay, so this is the type that the function evaluates to when invoked. This is where we invoke the function. This is where we also call the function. This is where we call the function or execute the function. Those three verbs mean the same thing. Call, invoke, execute. Run, that's another verb you can use. This is where you call the function. This is where we define the function. This is the function definition. And we can call it any number of times. We can call it, down here if we want. Oops, is even. We can call it any number of times. We can invoke it any number of times. But we can only define it once. And this is where we're defining it. Now this function takes what's called an argument. This is the data that's passed into the function so that the lines of code, the statements of code inside the function have access to this data that's passed in. You don't have to pass in anything. It could be an empty list of variables. Or we can pass in more than one variable. We could pass in another variable. Call it integer k, like that. Now this won't compile, hopefully. No matching function for call to is-even. See, we're defining is-even as taking two arguments. But when we call it, we only pass in one argument. So we would have to pass in two arguments so that we're using it in the manner in which it's defined. I'll just pass in a 0. Now it'll compile, and then of course it works correctly as well. So this is called the argument list. And where we define the function, we have to give the data types of the arguments, or the parameters of the function. Yes, we call them parameters. So is-even now has two parameters, n and k. We don't need the k, I'll take that out. It's a little distracting, but I wanted to show you the general case. Now look at this n here. And I see an n there. And there's an n there. And there's an n there. How many n's are there? How many variables are there? It's like, how many Davids are in the room right now? Raise your hand. How many Davids? I'm the only David, right? It's only one David. So if there was another David in here, there'd be two Davids, right? So I could say the word David, David, David. I'm David, David, David. How are you, David? Now I use the word David, but I'm referring to another person. So here, n is referring to a data stored in memory. Okay, n is referring to this storage location. How many storage locations are referred to by n? In the class, David referred to two people, okay? We used the name many times. Here we're using the name n many times. And how many separate storage locations are we referring to with all these mentions of n? Can anyone say? Not one. Two. Two. This n here is different than this n here. Actually, this n here is defined there. is defined here. So n exists here. And we say it has scope where it's defined here, and then it's defined all the way in through there. That code, whenever it uses the name n, refers to this initial, this first creation of storage named n. And then when we invoke this function is even, and we're using the name n. And this parameter here is also called n. But that's just a coincidence. Well, not a coincidence, but it just happens to be the same name. The value n here, the value that n represents, is copied into this other n. So a copy is made in the arguments. And this n here is that we're referring to in this statement is the copy. It's the second version of n, the second storage location that we happen to call n. So this name here, we could call this k. This code is identical. It's absolutely identical in terms of the machine instructions. There's no difference in the instructions, the machine instructions that are generated here. We just give it a different name.
You had to change the is even to k as well.
Change what?
The if is even, you don't have to change that too. You change it to k. When you're calling if statement.
Oh, here?
Yeah. Should that be k as well?
No. That's the point you're making. It's good. Think about this. This k that's declared here is only visible inside the body of the function. It is not visible anywhere else. If I call k down here, it's going to say, what's k? It's going to say unknown identifier. K is not defined because this k is only visible inside the function body. That's called this is called a scoping rule. Watch that. Error. Use of undeclared identifier k. What do you mean undeclared? We declared right there. Oh, it means undeclared identifier in the scope in which it appears here. Okay. Now watch this. If we declare k here, give it an 8, say, and I want to. This should be that operator, just to keep it clean. Let's go ahead and declare this k 8. Now it runs. We'll print the 8. What happens if we did this? What's going to happen now? Is k, like, it's done sequentially. K is not defined here. It's defined after we use it. So the compiler is going to complain about that. Use of undeclared identifier k, because it hits the point, it does this sequentially. The compiler gets here and says, oh, print k, but you didn't define k. Well, I will, but it's not going to look ahead for you. So this k that we were just operating on is a separate k from this k. It's as if David was in the room next door, and there's a David in here. They're just in two different places. It's the same name. They're just in two different. I can send David a text message here on my phone. Right? Well, it's a David to a David, but still, there's communication through this interface here, this argument list. But the name is just whatever name you want to give it. Oh, here's another thing. Now watch this. Let's suppose, and this will be the last thing we do. Let's suppose we take k and we multiply by 2, okay? If it's even, it'll remain even. If it's odd, it'll become odd. It'll become even, right? So everything is turned into even. Right, this is the last thing we do. The 7 becomes even. 8 remains even. Now here, watch this. I'll print n. So we read in n, then we print n, okay? Even. So we read n as 8, and we print n as 8. So we read in n, which is 8. We run the function, get the result, print even. And then we print n again, 8. But what if we did this? What is the behavior of this function going to be? Has anybody read about this? See, what we've been talking about so far is pass by value. That means make a copy from the calling code, copy the variable state into new variables. Here we're passing by reference. Here we're saying, hey, don't make a copy of the argument coming in. Let the parameter k refer to the same thing that the variable refers to in the calling code. Right? Don't make a new name. There's not 2 Davids in the room anymore. There's only 1 now. So this k will now refer to the same storage location that n refers to. So that here, when we modify k, we're modifying the same storage location that n refers to. So when we run the code now, if we read in, if we read in 8 into k, if we read in 8 into n, and then we call the function is going to double n and we'll print 16. You see that? See, this is called a reference parameter. So they have a different semantics, they say. This has different semantics. It means something differently. To call the function with this variable n is now like I'm sharing a reference to the same data storage with you, Mr. Function. So if you modify that data storage, then you're doing it with my blessing. And so a lot of times you'll see, well, I don't want it. Maybe k is not an integer. Maybe it's a large object. I don't want to make a copy of a large object. I want to pass in a reference to the object without making a big copy of it. I want the code to be to run nicely. So, but I want to pass in a reference to k, but I don't want the function to modify my data, just to read the data. So we use this keyword const here. We say, yeah, I'm giving you a reference, but you better not change k. It should be constant. That's a constant reference. So now the compiler will refuse to build this function, to build this code. Error, read-only variable is not assignable. So we have to get rid of this. This is the line where we modify the state of k. Well, we declared k as const. So we have to take out the line that tries to modify k. Now we got a compilation. So there it is, functions. That's the, there's not much else I could say. Oh, there's one other thing I want to say here. What if we wanted to define the function here at the bottom of the program, just because It's how we want to organize the code. Well, this will not compile because
There's code above it that requires an operation from.
say that again.
There's code inside main that requires
Yeah.
boolean function.
Yeah, so is even is now undeclared. It's just like how we moved, remember when we moved the declaration of K below where we use it? So we use is even here. The compiler, remember the compiler is going sequentially down through this file. It doesn't look ahead. It says is even. What are you talking about is even? I don't know what that is. Then it terminates right there. So you can do what's called a forward declaration, and you can tell the compiler, hey, I don't want to give the implementation of is even. Okay, I want to do the implementation because it's so big and messy. I want to do the implementation somewhere else. But compiler, I want you to know that is even is a function, and I'm going to implement it later. But take my word for it, compiler. Here it is. Is even takes a K, and it's a constant int reference, and it returns a bool. So that's enough information for the compiler to process this line. And then when it gets down here, then it knows that is even is defined. So now it runs. Now watch this, one last thing. Let's suppose we took this one out. What's it going to do? Anybody know? I'm only going to guess too, okay? But I'm going to guess with 97% confidence. It's not a compilation error in a sense. It's called a linkage error. We told the compiler that is even exists. But when it gets, so it does the compilation phase correctly, but then when it gets to what's called linking, and we don't have time to get into that, and I'm not going to get into it in detail, that it won't be able to, it has to find these unresolved references. It's going to look for is even. It's going to say, I can't find is even. Let's see if I got that right. I said a 75% confidence. There it is. I got it right. So LD is the linker, and the linker's complaining. It's saying is even. It's saying the symbol is not found. So that's different than, see, compilation is in two steps. It's really this compilation step followed by a linkage step. And you'll see that as you go forward and write code, you're going to see linkage errors. Just thought I'd give you a heads up on that. So that's it for today.